Now let t is equal to sin theta. Now remember this term, let t is equal to, so our I is equal to 1 by 2 integration 0 to 1 t cube upon under root 1 minus t square dt. Now let t is equal to sin theta. So when now this is a limit of t, so when t is equal to 0, sin theta is equal to 0, so theta is equal to 0. When t is equal to 1, theta is equal to pi by 2. Okay. Now also t is equal to sin theta, so dt is equal to cos theta d theta. Dt is equal to cos theta d theta. So put all this value, we get 1 by 2 0 to pi by 2. Our integration is now from 0 to pi by 2 t cube, so that is sin cube theta. This is 1 minus sin square theta, so that is cos square theta, and under root of cos square theta, so you will get cos theta, and dt is equal to cos theta d theta. So this is equal to cos theta d theta. So this cos theta will be cancelled out. Finally you will get 1 by 2 integration from 0 to pi by 2 sin cube theta. And now again we can apply previous formula. Then 3 is an odd number, so this equal to, we can write 1 by 2 3 2. So this equal to 1 by 3. So the answer of the given integration, the value of the given integration is 1 by 3. So here we complete the solution, question number 3C, first part and second part. Now next question, question number 4A. First part, evaluate integration from 0 to 3 dx upon x minus 1 if possible. So question number 4A, first part, that is integration 0 to 3 dx upon x minus 1 dx. Now this is an example of the chapter of improper integral. You can see the denominator becomes 0 when x is equal to 1, and 1 is between 0 to 3. So we cannot direct solve this integration, the value of this integration. So that's why we have to convert here. If you want to write down here, the integrand is infinite at x is equal to 1 in integration 0 to 3. Hence I cannot be evaluated directly. Hence if we can say this is I, then the value of this integration I cannot be evaluated directly. Because of the value of the this term x, the denominator becomes 0 when x is equal to 1. So the integrand is infinite at x is equal to 1, where 1 is between 0 to 3, right, the limit of this integration. So hence I cannot be evaluated directly. So we have to convert, we have to part of this, this I can be written as this equal to integration 0 to 1 dx upon x minus 1 plus 1 to 3 right, because of the integrand is infinite at x equal to 1, so that's why we converting this integration into two parts, 0 to 1 and 1 to 3. Now first of all we find this integration 0 to 1, and now the integration is infinite at x is equal to 1, so that's why this, suppose this is I1, call it I1, this is I2. The first part is I1, the second part is I2. So first of all we find I1, where I1 is equal to integration 0 to 1 dx upon x minus 1. So let's see, find I1, that is equal to integration 0 to 1 dx upon x minus 1. Now this can be written as b tends to 1 minus, right, 1 minus integration 0 to b dx upon x minus 1 dx. Now the integration of 1 upon x minus 1, that is log x minus 1 log mod x minus 1 0 to b. So this is equal to, first of all we have to put b, so this is equal to log b minus 1 minus, when we put 0, log modulus 0 minus 1, so modulus minus 1 is 1, so log 1 becomes 0, right. So we don't need to write here, so the final is log modulus b minus 1. Now you can see b tends to 1 minus, that means what, b is less than 1, so in that case the modulus of b minus 1 become 1 minus b, right. The modulus of b minus 1 become 1 minus b, so this is equal to log 1 minus b. And now when b tends to 1 minus, this tends to minus infinite, this tends to minus infinite, because 1 minus b tends to 0 plus. In that case when b tends to 1 minus, 1 minus b tends to 0 plus, and log, and the value of this is minus infinite. So the first part I1 is minus infinite, so we don't need to find out the second part, because the first part I1 is minus infinite, right, and I is equal to I1 plus I2, and we want to check that the given integration is convergent or divergent. So definitely it is convergent, because the first part is tends to minus infinite, so either second part is convergent or divergent, there is nothing change, okay. So the I is equal, the value of this integration is divergent. The next question, evaluate minus infinite to infinite dx upon 1 plus x square, the second part. So question 4a, the second part, I is equal to minus infinite to infinite dx upon 1 plus x square. Now this is also can be converted into, this is also example of improper integral, and this can be written as minus infinite to 0 dx upon 1 plus x square plus integration 0 to infinite dx upon 1 plus x square. This is equal to I1 plus I2. So first of all we find out the value of I1 and then find out the value of I2, right? I1 is integration from minus infinite to 0 dx upon 1 plus x square. So here is I1. Now this equal to a tends to minus infinite integration a to 0 dx upon 1 plus x square. So this equal to a tends to minus infinite, the integration of 1 upon 1 plus x square, that is tan inverse x. So this equal to tan inverse x a to 0. So this equal to a tends to minus infinite tan inverse 0, that is pi by 2, sorry, tan inverse 0 is 0 minus tan inverse a, right? Tan inverse 0 minus tan inverse a. Now tan inverse 0 is 0, so this part is 0. Tan inverse a, where a tends to minus infinite. So basically we want to find that in which angle the value of tan is minus infinite. So that is, the answer is minus pi by 2. So 0 minus the value of this tan inverse a, where a tends to minus infinite, is minus pi by 2. So this equal to pi by 2. This equal to pi by 2. So this is just a value of I1. Also we want to find I2, where I2 is 0 to infinite dx upon 1 plus x square, right? Here we find I1, where I1 is integration from minus infinite to 0 dx upon 1 plus x square. Also we want to find I2, where I2 is integration from 0 to infinite dx upon 1 plus x square. So here I2, that is integration 0 to infinite dx upon 1 plus x square, that is equal to b tends to infinite integration 0 to b dx upon 1 plus x square. Okay. Now again the integration of this term is tan inverse x. So b tends to infinite tan inverse x, where b tends to infinite tan inverse x 0 to b. Now this equal to tan inverse b minus tan inverse 0, but we know that tan inverse 0 is 0, so we don't need to write here minus tan inverse 0, but tan inverse 0 is 0. So just tan inverse b, and now b tends to infinite and tan inverse b. So that is equal to pi by 2. The value of tan is infinite when the angle is pi by 2. So the answer is pi by 2. I1 is also pi by 2, I2 is also pi by 2, and I is equal to, what is our I? I is equal to I1 plus I2. So that is equal to pi by 2. I1 is also pi by 2, we get. I2 is also pi by 2. The value of I2 is also pi by 2. So this equal to pi, right? So the final answer, the value of this integration from minus infinite to infinite dx upon 1 plus x square, that is equal to pi. The next question. Question 4b. Find the volume of the solid generated by revolving the region between the parabola x is equal to y square and the line x is equal to 1, about the line x is equal to 1. So first of all we draw the graph where the parabola x is equal to y square and line x is equal to 1, and also just try to remember we have to find the volume of the solid generated by revolving the region between these two curves, right? X is equal to y square and line x is equal to 1, about the line x is equal to 1. So question number 4b, let's see how we solve. the graph of this term something like that. This is a parabola, x is equal to y square, right? This is a line, x is equal to 1. This is the line, x is equal to 1, and this is a parabola, x is equal to y square, right? Now this line x is equal to 1 intersect this parabola at the point 1 1, and here 1 minus 1. This is 1 0, this is 0 0. Okay, so first of all just try to understand this graph. Now this is x axis and this is y axis. Now we transfer the origin. To find the volume, we transfer the origin O to A 1 0. We transfer this origin to 1 0. So hence we obtain x is equal to, because of we are transferring the origin 0 0 to 1 0, x is equal to capital X plus 1, right, and y is equal to capital Y. So the equation of the curve becomes, now you can see the curve is x is equal to y square, right? The equation of the curve becomes, our curve is what, x is equal to y square. Now x is equal to x plus 1 and y is equal to this capital Y. So that's why this capital Y square, that is equal to capital X plus 1. This is our curve, x is equal to y square. This is parabola, right? So now our new curve become capital Y square, that is equal to capital X plus 1